Please welcome to the stage Chris and Tim.
Everyone put your hands together for Mojo and the incredible breakdancers. How awesome was that, eh? So we are so excited to have everyone here today for ModCon. We have an incredible amount to share. So let's get started. Chris, take it away.
Awesome. Welcome, everyone. In May, we announced 2 breakthrough technologies to the world. These were Mojo and the AI engine. We shared our common enemy. That enemy is complexity and fragmentation. Drives developers crazy. The other thing we did was we unveiled a better future for AI. A simpler, unified, and more efficient AI stack that actually works. And we've just been blown away by the response. Since our launch in May, we now have this amazing, incredible developer community with over 150,000 developers. This represents more than 50,000 enterprises. And we have an incredible developer community. We call it the Modverse. This has tens of thousands of developers all across many different kinds of platforms. And these folks are across 150 different countries in the world. It's pretty amazing. And this is all just in just over 6 months, which is pretty phenomenal. So given where we've come from, let's zoom back out and talk about what's new. So we'll start with Mojo. Mojo, as hopefully you know, is the first programming language for all AI developers. And of course, it's also for people who love emojis. And who doesn't, of course. And the response has been incredible. Many people are speculating about just how big Mojo can become. And as of today, we have tens of thousands of developers from all over the world using Mojo, and we're thrilled to be on a journey with them today. But let's look at what's next. And now, I'd like to invite up Tatiana to share what is the latest in Mojo.
Thanks, Chris. Since May, we've implemented numerous improvements to Mojo. We shipped 21 updates, released Mojo SDK for local execution, enabled support for Apple Silicon, and added so many new features. Today, we are excited to take the next step and announce the release of Mojo 0.6. We don't have time now to go into all the new incredible features, but I like highlight big one that we know many Mojo developers have been eagerly waiting for: traits. Mojo 0.6 introduces traits, which allow expressing generic algorithms without sacrificing performance. Traits are one example of how we bring proven techniques from languages like Rust to Mojo, enabling Python developers to learn and benefit from modern language technologies. To learn more about all the new features in Mojo 0.6, please check out Mojo changelog. It's huge. We continue to invest an enormous amount of energy into Mojo because the stakes in AI are so high. We want to lift the state of AI software and unleash the creativity of all Mojo developers, whom we call magicians. We are thrilled to see the things that magicians have built so far, spanning AI, bioinformatics, and many other areas. Let's zoom into just one example. Llama 2 is one of the world's most popular large language models, created by Meta and open sourced for the world. Because it is open source, it has been widely re-implemented. Many people use it, so its efficiency is really important for a wide range of use cases. When we launched the Mojo SDK release, an external developer, Aydyn Tairov, quickly ported the Llama 2 Python implementation to Mojo. But instead of me talking about it, we've invited Aydyn to tell you more about his project, along with Jack, Mojo's developer advocate.
In early September, we received a lot of excitement from the community. The first big project that we saw was llama2.mojo, which Aydyn Tairov, one of our community members, built over the course of one weekend. Here's Aydyn to talk about his project.
The idea was to take Andrej Karpathy's simple Llama 2 inference implemented in C and create a Mojo port. I found the Mojo syntax to be extremely efficient for this task. After utilizing native Mojo features like vectorization, parallelization, I found that the performance of the inference improved significantly. After conducting some extensive benchmark, I was surprised. Mojo outperformed renowned open source implementations written on C or C++.
Mojo is the top performer across most benchmarks and on different types of hardware. But the striking thing is how little lines of code it took to implement this, and how little amount of time it took him to actually learn the language and then write the implementation. Here's an outline of the 1,000 or so lines of code it took to implement this project. It's all pure Mojo. It runs across different architectures and operating systems, and you don't have to handwrite any assembly or call into C libraries to unlock performance. This is a demonstration of running it through the CLI. So I'm just going to bring up all the different options that you can pass in, and now I'm going to run one of the faster models. You can see this is running at 780 tokens a second on CPU, and you can see changing the prompt changes the output. Now I'm going to run the 1 billion parameter chat model. Now you can see this runs slower. It's only going at about 19 tokens a second, but we're excited to show you how we can get this running much faster with even fewer lines of code with some features that we're announcing today. What's been really encouraging is how friendly and engaged the community is. We have programmers from all different kinds of backgrounds, from systems engineers to AI researchers, which has been great to see because a major aim of this programming language is to combine these two worlds together. Here's Aydyn describing his experience building this project with the community.
The Mojo community is amazing. When I joined the Discord, I received tremendous help. Subsequently, once llama2.mojo project got some traction on GitHub, I received multiple pull requests from community members that improved performance even further. I encourage everyone, regardless of experience level, to give a Mojo a try.
How amazing was that? Now, I'd like to pass it back to Chris to tell you more about our plans for Mojo.
Thanks, Tatiana. It is incredible to see what magicians can do when they have superpowers. Just to recap, Aydyn took Llama 2 from Python, a Python implementation, and built a Mojo implementation over a weekend. It's just over 1,000 lines of code. That's amazing. It's implemented all the way down to the metal in pure Mojo. So this community of Mojicians is wonderful, and our goal is to continue to expand it. Now, what we want to do is pull in even more people, and so we're doing that by releasing Mojo 0.6, packed with cool features. But we're also starting on our path to open sourcing Mojo, because we think that will help Mojo go much further, much wider, and involve even more people. And so we're starting with the documentation, the manual. This is a good step. But soon, we'll also start producing nightly builds. And coming soon, we'll be open sourcing standard library. We think this will be a huge step forward to getting more and more people involved and building more Mojo libraries. So we'll continue doing this, but we're also going to do it right. We're using an Apache 2 license, and we're using an external source of truth for the code so that everybody can participate and drive Mojo forward together. So we are very excited about giving developers superpowers and expanding the Mojo community. And we'd love you to join us. If you'd like to join the Modverse, you can join us on Discord or GitHub. But while Mojo is what Modular is best known for, we're not just here to build a language. I'd love to invite Tim up to share what Mojo actually enables.
Woo! Thanks, Chris. At Modular, we haven't just developed the best programming language for AI developers. We've also created the world's fastest unified AI inference engine. It meets you where you are, out of the box, and it is compatible with all native framework operators and supports all the things you'd expect: dynamic shapes, quantization, and all your existing custom operations. And it works with all major AI frameworks like TensorFlow, PyTorch, and Onyx, and all major CPU server hardware like Intel, AMD, and ARM, giving you maximum compute portability. It delivers incredible performance, offering real compute multipliers or performance speedups for your AI workloads. Out of the box, with no code changes on Float32 precision, we are, on average, 2x faster on a huge range of model architectures when comparing to the latest versions of TensorFlow, PyTorch, and Onyx, across Intel, AMD, and ARM CPU hardware. And we've been working with some incredible partners who have found tremendous value in what we've built through our AI Engine's early access program. Now, today, we are excited to announce we're expanding the early access program to let more of you in. Go to modular.com to get added to our AI Engine's faster rollout list and get access to all these incredible benefits right now. So, that's 2 amazing breakthroughs with such amazing progress just over the last 6 months. But now you're probably wondering, what's next for Modular and our infrastructure? Before we dive in, let's reflect on how much AI has changed across the last 10 years. From tiny CNNs in 2013 to now massive compute and memory-intensive LLMs scaling clusters of machines. AI has changed enormously. And while the models and use cases have massively shifted, the software infrastructure has just become more bloated. We see more and more abstraction layered and point solution after point solution created. None of these technologies interop well together. In fact, the AI software we use today was never designed for generative AI or large models at all. Let's take a look at a common AI pipeline of today. Many developers we speak with just care about taking a pre-trained model, doing some pre-processing and fine-tuning on their data, getting an inference result, and then serving it up to the user. And here are just some of the technologies developers have to use to achieve that today across different languages, model sizes, memory, and computational footprints. It's total madness as an industry. What are we thinking? We need a new approach for the AI of today, generative AI, which will help us scale into the AI of tomorrow. And I'd like to introduce Eric, who's going to talk about exactly that.
Thanks, Tim. Today I'm excited to introduce everyone here to the next generation of AI infrastructure. We call it MAX. MAX stands for the Modular Accelerated Execution Platform. And it's composed of 3 core components: the engine and the Mojo programming language you're already familiar with, as well as a brand new serving module. Together, they represent an integrated, composable suite of products that simplify your AI infrastructure, enabling you to develop, deploy, and innovate faster. And Max is built from the ground up to support all your generative and traditional AI pipelines. But before we jump in, let's take another look at that diagram that Tim just showed us. To power your full inference pipeline from data to deployment, you have to use a crazy number of technologies and tools. However, with Max, you get one solution that works across all the components of your pipeline, enabling you to get rid of all those bespoke tools and utilize a single tool chain for all your inference needs. You'll be able to utilize the Max engine to do inference on fine-tuned models, Mojo to extend those models to support data transformations and novel algorithms, and Max Serving to easily deploy those optimized models into any cloud service. Now, let's explore exactly what this means, starting by opening up the Max engine. Inside, you'll find Python, C, and Mojo APIs for integration into any application or server. Simple and intuitive tools that enable you to benchmark, visualize, and profile your models. The world's most high-performance hardware kernels. A state-of-the-art compiler that unlocks generic fusions and other model optimizations. And a low-overhead, heterogeneous runtime. But how does this all benefit you? All this technology combines to make the Max engine the fastest inference library on the planet. It executes all your models from all popular AI frameworks like PyTorch and TensorFlow out of the box. This includes full compatibility with all the framework operators, quantized types, and dynamic shapes. And it can even support all your existing custom operations. The Max engine is up to 5 times faster than existing infrastructure, supports execution across all your CPU architectures, and is fully extensible via Mojo. And very importantly, it supports all the most popular Gen AI workloads, like Llama 2, Stable Diffusion, Whisper, and many others. But of course, this doesn't mean you have to further fragment your stack. Max also supports all your traditional AI use cases, like recommenders, image classification, object detection, and so much more. In addition to the Max engine, we also provide highly compatible serving infrastructure. Max Serving is a simple set of APIs that natively integrate with your existing serving stack, making it easy to serve models with the Max engine. It provides drop-in compatibility with existing inference servers such as NVIDIA Triton, TF Serving, and TorchServe, and integrates easily into any existing container orchestration services such as Kubernetes. And of course, all this is powered by Mojo. So that's the modular accelerated execution platform, which gives you all the components you need to deploy low latency, high throughput inference pipelines into production. But why should you really care about Max? It goes without saying that AI, and in particular generative AI, is poised to transform the world that we live in. But there's a problem. 1 year ago, our good friend Sam Altman described the cost of running ChatGPT in production as eye-watering. And recently, OpenAI decided to limit the number of ChatGPT users due to enormous challenges scaling the model, the user experience, latency, capacity, and costs. Now, this is not to pick on OpenAI, which I think we can all agree is doing amazing, amazing work, but instead to point out that while everyone is enormously excited about Gen AI, what many don't realize is that it's extraordinarily difficult to scale. Even for the world's largest and most sophisticated companies with the best talent. So you might ask, why is this the case? Well, there are a few reasons. For one, Gen AI models and data transformations are massively compute intensive, making them difficult to deploy within latency and cost budgets. New Gen AI research innovations are being developed all the time, but it's incredibly challenging to extend the existing infrastructure to support those new use cases. So developers resort to adding new bespoke tools to their stack. Deploying a server is challenging enough with fragmented inference tools, but companies also want to bring Gen AI to everywhere their users are. That includes laptop, mobile, console, which is nearly impossible today. And it's difficult to find and hire talented AI engineers that are capable of piecing together a modern Gen AI serving stack with all these low-level technologies. But Max changes everything, right? Max engine provides unparalleled out-of-the-box performance that unlocks positive Gen AI unit economics. Mojo makes it easy for users to extend their workloads, maximizing the performance of their data transformations, or adding novel research algorithms to their models. Max enables execution of models across a variety of server hardware and platforms to take advantage of cloud cost arbitrages or better utilize idle CPUs in a data center, and even deploys to edge devices. And of course, with Max, it all just works, enabling your engineering team to do more with less. So there you have it. All this represents Max, unified, simple, powerful AI developer infrastructure that enables any organization to actually bring generative AI to production, both economically and efficiently. And most importantly, it works with your data on your models inside your infrastructure in a secure and scalable fashion. Instead of taking control of your models away from your team, Max gives you and your development team superpowers. Now, who wants to see Max in action? Nice. To demo, I'd like to welcome Nick to the stage to show us just how powerful Max truly is.
Thanks, Eric. Today, I'm going to show you how to use the power of the Max platform in today's AI workloads. These workloads are not just matrix multiplications or accelerated endpoints. They often require multiple models as well as complex pipelines before and after. We're going to keep with the Gen AI theme and use Stable Diffusion, a pipeline that generates images from text input. This is an example of what Stable Diffusion often looks like. It has a text encoder, UNet, and image decoder models, plus some text encoding and tokenization steps. This Python is typically written using multiple languages, including Python and C++. Now, let's take a closer look and use the power of Max to make this project go fast.
This Python code here generates images using the Stable Diffusion pipeline, including the pre-processing steps and the 3 models. Let's get started by using the Max Engine APIs. Max provides APIs for Python and C to meet your workload needs where they are. And here we are using the Python API. First, by importing the engine from the Modular package. Next, creating an inference session to use with our models. And now we're going to replace the existing calls to the Stable Diffusion models with calls into the Max engine. These APIs allow this Python code to simply drop in and use the power of Max. Now let's run the script and see it work. Out of the box, the Max engine already provides accelerated workloads for this whole suite of models. By switching to Max, we're accelerating this pipeline by around 2x. Cool. Some generated AI. Awesome. But Max isn't just an acceleration endpoint. It brings a whole ecosystem to empower your engineering team. Now let's jump back into the demo, and I'll show you more. Here, we have ported the previous Python example into Mojo. This enables to power even more of our Stable Diffusion pipeline. And let's do that by accelerating our pre-processing steps. This file here contains a performant text tokenizer all written in Mojo. Often, pre-processing steps such as this require teams to manage bottlenecks in Python, introduce other languages, including C++ and Rust. Max and Mojo simplify and accelerate these workloads. Now that we're back in the pipeline file, we're going to import the tokenizer, then create an instance of it and point some vocabulary at it. And finally, let's just drop into our pipeline, and let's see it in action. Here we are calling Mojo to run the whole suite, including our new pre-processing Mojo code. Who doesn't love Gen AI? Now, we've empowered all of the Stable Diffusion pipeline using the Max engine in Mojo. What else could we do? Let's step back for a minute. There's always new advances and techniques in AI and ML. Often using these techniques requires owning the full stack, working with vendor libraries, hacking on existing frameworks, and hand-modifying models and kernels, all with custom toolings. For example, one of these techniques is taking advantage of lower bit precision, such as 4-bit math kernels. To even try a technique like 4-bit math, it takes ML engineers weeks to months to evaluate. This involves forking, hacking, and building most of the infrastructure stack to simply test and evaluate, and often only works for one model. And this is because of the current fragmentation in the software stack, as Eric discussed earlier. Max changes this. It empowers you to just use them. Now let's jump back into our demo, and I want to show you this power in action. The bulk of the compute in our Stable Diffusion project is the UNet model, and we're going to modify this model to use 4-bit math kernels, all with the Max engine in Mojo. In this file, we have a Mojo kernel we've written with 4-bit math. It has all the language syntax features that allow us to do this. Now let's jump back into our Mojo program. We're going to instantly apply 4-bit acceleration to the UNet model. First, we need to point it at our new Mojo kernel package. Then we're going to use the Max engine APIs to load our new kernels for the UNet model. And for something fun, let's spice up our image prompt. Now let's see it work. The Max engine has loaded and is executing our new 4-bit math kernels. All of this is done without rebuilding frameworks, multiple languages, working with upstream vendors, or managing complex tool chains. It all just happens in Max. Now let's zoom out and take a look at what our Gen AI Stable Diffusion pipeline looks like today. First, we drop Max in to accelerate the 3 models that make up the Stable Diffusion by using our engine APIs. Then we upgraded our pre-processing and tokenization logic with Mojo. And we took advantage of 4-bit acceleration techniques. And if you want to go all the way, you can even replace the Python outer loop with Mojo getting Python out of production for good. Now, I'll throw it back to Tim.
How awesome was that, right? Amazing. Max gives, thanks Nick, Max gives your developers AI superpowers. A single platform for all your use cases with fewer things that work better. It provides unparalleled performance across model and data. And of course, it all just works. The exciting thing about the Max platform is that it's designed to be modular, haha, allowing you to mix and match individual features Nick just demoed, or using everything together as a single unified solution. And speaking of low-level control, let's talk about what Max can do for those who are pushing the limits of AI inference. We've seen a rise of disposable frameworks written purely in C or C++, like GGML, MiniGTP4, Whisper, and Llama 2. But why, you ask? Why were these created? Well, it's because these developers wanted to shed the baggage of traditional AI frameworks with now huge external dependencies. They wanted to focus on inference performance rather than training, and they just wanted to move faster to optimize performance across hardware for the most important models. Well, we want Max to enable these pioneers to move even faster, and that's why today we're also introducing the Graph APIs for the Max platform. The Max Graph APIs will give you low-level control over the engine with minimal external dependencies. You'll get direct programmability over the hardware, including high-level abstractions and the ability to drop down to the metal when you need it. And the ability to extend your pipeline with pre-processing. You can tweak your model topology and build your own APIs. But rather than tell you, I'd like to introduce Dan, who's going to show you.
Thanks. As Tim said, the Max Graph APIs are incredibly powerful. They will enable you to build, import, and tweak the same data flow graphs that power the Max engine itself. They will give you access to a simple and easy-to-use API that leverages powerful and familiar concepts. Earlier, Aydyn presented llama 2.mojo, which was awesome. And he gave us inspiration and made us ask the question, what if we gave Aydyn and others like him the power to access the Max engine directly? Let's see how. In the previous demo, we saw how the Max engine delivers top performance using powerful graphs, like the one shown here. Our Graph API lets you build and modify such graphs directly, without depending on any other tool or framework. Just pure Mojo. This is meant to serve as a low-level foundation API, but it's powerful enough to build inference models without too much boilerplate, like this RMS norm layer that you might recognize here. And we've put that to the test. The snippet you are looking at is from our own implementation of Llama 2, written in Mojo using Max Graph APIs. Even with a low-level API, our code benefits from the better readability of Mojo. To the left, you see our graph code, and to the right, GGML's llama.cpp implementation. Take a moment to compare the line count. Max is over 30 times less code. What about performance? Well, we think it's pretty fast. Here it is, producing a prompt in real time on an Intel Skylake CPU. Using the power of the Graph APIs and Max, we were able to run faster than Onyx in Python, faster even than llama.cpp and llama 2.mojo, and with up to 30 times less code. That's right, 30 times. How awesome is that? The Max APIs enable you to develop with a flexible engine and full programmability for power users. And I can't wait to see what you build with it. Now, I'll hand it back to Tim.
Great work. Thanks heaps, Dan. That was amazing. So, the Max platform is incredible. But you might be wondering, how do you get access to it? Well, today we are announcing that Max will be available to some customers in preview. Go to Modular/Max to request early access, and it will be generally available to everyone in Q1 next year. So to recap, With Max, you'll get the ability to test on your favorite local machine hardware. You'll be able to benchmark performance up to 5x. You'll be able to roll out and test model inference infrastructure locally. And of course, this plugs in seamlessly to NVIDIA Triton and other frameworks. And you'll be able to interop with the engine and Mojo. And today, we're also announcing there'll be 2 editions of Max that will be available. The Developer Edition, which will be free for personal use, up to 16 cores and enable single-node distribution. And the Enterprise Edition, which will enable production usage, unlimited scalability across hardware, and both single and multi-node distribution with pricing that will give you the flexibility and control to only pay for what you use. We are also announcing that the AI engine and early access program we talked about earlier is all graduating into Max for a single unified offering. And this is how easy it is to get started with Max. Just download our installer, like you can from modular.com today, type out Modular install Max, and you'll get everything on your local machine. Now I'd like to call up a very special guest, Bratin Saha, who leads all of AWS's AI services, to join me on stage. Bratin, welcome. We are so excited that you're here.
Thank you, Tim.
Take it away.
More customers do their machine learning and AI on AWS than anywhere else. And that is because we are really focused on helping customers address the key considerations that help them build and scale the generative AI. Today, let me talk briefly about 3 of these important considerations. Providing customers the choice and flexibility to use multiple models, providing them a low-cost and highly performant machine learning infrastructure, and providing them many generative AI-powered applications. Let me now get to Amazon Bedrock. Amazon Bedrock provides customers with access to state-of-the-art models, many of them. You can use these models as is, or you can also customize them with your data through techniques like fine-tuning or RAG. You can also use many other generative AI capabilities like Bedrock agents that can act on your behalf, for example, to make travel bookings. Let me next talk about our machine learning infrastructure and talk about SageMaker, which provides a fully managed end-to-end infrastructure to build, scale, tune, and deploy our models. And we have a number of purpose-built generative AI capabilities. For example, we provide self-healing clusters that also come with specialized distributed training libraries that improve performance by up to 40%. Or we have specialized inference capabilities that reduce cost of inference by up to 50% and reduce latency by up to 20%. We also have a specialized workforce for data labeling. So you can come in, get your data labeled and curated before starting on your Gen AI journey. The final component is Gen AI-powered applications, where we have a number of applications. We launched Amazon Q last week that we are very excited about, uses generative AI to transform how employees do their work. We have AWS Health Scribe, where we are deploying generative AI into healthcare. We also have capabilities in personalization and contact centers. And now I'm so excited that we are going to be collaborating with Modular.
Yes, today we are announcing a new exclusive global partnership with AWS, the world's leading cloud service provider.
That's right. We can't wait to be the first cloud provider to offer the Max platform stack on AWS across our marketplace and to our Graviton customers in 2024.
Amazing. Thanks so much, Bratin. We're super excited to partner with you.
Thank you.
And deepen our relationship. Now, you might be wondering, what does this all mean practically? We are starting with launching Max Enterprise on the AWS Marketplace in Q1 2024. And Max will be exclusively available to deploy to services like EC2, EKS, and even SageMaker. You will receive unparalleled low latency, high throughput inference that just works, with a familiar consumption-based pay-as-you-go pricing model. And of course, the AWS Marketplace will be the only place you'll be able to take advantage of Max on Amazon's Graviton CPUs, Amazon's high-performance processors for compute-intensive workloads. Max supercharges them, increasing Graviton performance by up to 5x and saving you up to 80% on cost. Again, all this is just out of the box with zero migration costs. So, what an incredible set of announcements. How about a big round of applause? But, that's not all we're here to talk about today. I'd like to hand it back to Chris to add something incredibly exciting to today's set of announcements.
Thank you, Tim. That's a pretty incredible set of CPU announcements we have today. But you might be wondering, what kind of AI platform doesn't have GPU support? So today, I'm very excited to give you a sneak peek into Max's support for GPUs. Now, we've completely rebuilt the entire GPU pipeline from the bottom up to provide the best possible developer experience for GPU users and researchers. Max meets you where you are. It can integrate with your AI pipelines. It can bring state-of-the-art compiler and runtime technologies to NVIDIA's amazing GPU architectures. And of course, Mojo brings about a new era of GPU programmability for the world. With Mojo, you get high-level abstractions that make GPU programming easy for people who are new to accelerators. But Mojo also gives you full low-level control and GPU primitives for the super experts who help drive the state-of-the-art forward. More than that, it also integrates with powerful NVIDIA tools like NVIDIA Insight. Now, lots of people today understand that GPUs are needed for the biggest Gen AI models. But the real power comes when you combine the strength of CPUs and GPUs together. Gen AI pipelines need preprocessing, need data loading. They need many other features to keep those GPUs fed. And only Mojo can unify both of these hardware types and do so gracefully, with high performance, and that allows Max to unify your development teams. This allows your teams to extend your stack for research, enables faster innovation, new models, new applications. This is what AI is all about. It allows you to utilize today's advanced high-performance hardware, and Mojo and Max together solve both today's problems, but it's also uniquely positioned to scale into tomorrow's use cases as well. Well, to share a real-world example of the pain that we're addressing, I'd like to invite up Michele Catasta, Vice President of AI Software at Replit, to share his journey.
Thanks, Chris. Back in 2018 at Stanford, I focused my research agenda on transformers applied to source code. I've become more and more obsessed with redefining the software lifecycle with AI, and I had no idea the field would make so much progress so fast. This professional journey led me all the way to Replit, where I'm running the AI team today. At Replit, our company mission is to enable the next billion software creators to go from idea to software fast. Now, over the years, we built a platform to rapidly develop software and easily deploy it at scale. You can use Replit to create projects in almost any programming language and framework with zero setup time. As of today, we have over 25 million users across 200+ countries. We have created 215+ million projects. So I'm sure it won't come as a shock when I claim that LLMs are key to the future of software creation. But today, I would rather focus your attention on why our users find them incredibly useful. Replit AI offers a variety of features ranging from code completion to proactive debugging of your coding and deployment sessions. As we speak, some of our users are building successful businesses on Replit without any prior software development skills, all thanks to the power of AI. Isn't that mind-blowing? So over time, we grew in conviction that our company mission couldn't be accomplished without putting our AI features in the hands of every Replit developer. And 2 months ago, we announced AI for All. It has been amazing to receive enthusiastic feedback from users all over the world. But as exciting as it sounds, it was also the most challenging launch I've ever worked on in my life. My team had to figure out how to scale LLMs in an economical and efficient way. Rarely in a startup you do 100x your workloads overnight. So let's take our code completion feature as a running example. To make sure we could scale horizontally without breaking the bank, we trained a bespoke 3 billion parameter LLM specialized on code completion, and even released it on Hugging Face under a commercially permissive license. So go ahead and use it however you like. Now, how do we make all of this happen? First, we had to develop Spark pipelines to create the pre-training datasets. Then, we trained the model using PyTorch and the Mosaic ML platform. And that was the easy part. So it turns out that only a few companies know how to deploy LLMs at scale, and we care deeply about the unit economics of model serving. If you think about it, this is a massive bottleneck for the growth of our field as a whole. So let me show you just a few of the challenges we encountered. As a starter, we couldn't rely on stock inference frameworks. None are powerful enough to enable the unit economics that would have allowed us to deliver AI features to all of our users. Then we explored custom LLM inference solutions, and we found them relatively easy to use for the golden use cases. However, they require substantial work to extend with custom logic. For instance, take the llama 2 models. They all use group query attention, but we had to contribute GQA support for our specific model architecture straight into the TensorRT LLM code base. And it doesn't get any easier when you want to test the latest and greatest in research, as you will likely find yourself regularly writing GPU kernels in CUDA C++. So overall, the model inference ecosystem is still fragmented, and the developer ergonomics are simply not there yet. Given our past experiences, you can imagine how thrilled I am by the release of Max. My team has been dreaming of building more advanced features in our inference stack, such as grammar-based decoding and advanced stopping criteria based on code syntax. This is why we're excited to work with a single toolchain to develop across CPU and GPU. Max will allow us to create a cohesive inference stack capable of squeezing the best performance, both from the host CPU and the AI accelerator. So trust me, the future for AI engineers looks much brighter today. Thanks, everyone.
Thank you, Michele. I love working with people who build and ship AI actually in production and who care how much it costs.
My pleasure, Chris. Oh, wait a second. Before I leave, when is Mojo coming to Replit?
Oh, that's a great
Right?
idea, man. Let's do it.
Let's make it happen.
Thank you.
Thank you. Bye, everyone.
Awesome. Now, with that as a nice introduction, let's dive in and see how this works. I'd like to invite up Bill to the stage to show us how it works in practice.
Okay. Thanks, Chris. Wonderful to be here. So why is the Max platform so powerful? Because it brings all you need for AI into a single platform, including GPU support. But how do we get Max to work with GPUs? Well, with Mojo, of course. It's the power of Mojo that enables you to scale to both CPUs and GPUs seamlessly. Let me show you a few awesome things that you can do with Max GPUs. So as mentioned, Max works on both CPUs and GPUs seamlessly. And to enable GPU support, one takes a model and just runs it with the GPU or with Max. We've put together a little demo website that just wraps over our Max engine on the A100 system. Let's first show how we run on the CPU to form a baseline. Let's give model a prompt, kind of slow. Actually, here we're showing the GPU part. And so it's very fast to run on the GPU here. So the green one is showing the GPU results. So we've given the GPU, the model run on GPU as a prompt, and super, super fast. The response rate is so much fast. And this shows how one can seamlessly utilize the GPU from within Max. But how about the implementation? Let's lift the kernel a little bit and show you how we built Max with GPU support. It's all built in Mojo, of course. We're going to take a look at the attention block in the next example, a key building block of LLMs. So let's fire up a Jupyter notebook and show how our GPU development workflow. Here's the entire implementation of the attention block in Mojo. Note that the implementation is quite simple. In fact, it fits on one screen. And with Max, you have access to the full power of the GPU, even low-level implementation details. But we've built a lot of abstractions. And unlike existing approaches that make GPUs easy to program, we're not sacrificing performance here. This code is 2 times faster than OpenAI Triton. So let's do the obligatory one-line change to the notebook to show how easy it is to experiment with the Mojo workflow. Suppose I want to examine the best block size or thread crank configuration. Of course, I can do that via Mojo's auto-tuning, but let's do that manually. In fact, while we're talking, I ran 3 different configurations and picked the best one. Here's an example of the plot showing the 3 different trials that I've done. Through Max and Mojo, we're able to accelerate developer velocity by having faster iteration time when developing GPU code. What's even cooler is that all the benefits of the Max platform translate to the GPU. For example, automatic kernel fusion. But it doesn't stop there. Max seamlessly integrates with the entire NVIDIA ecosystem of tooling, because the entire point of GPU programming is to get performance. But to get performance, you need to understand what the code is doing. And NVIDIA has developed awesome tools to understand the performance of GPU code and how to increase GPU utilization. So let me show you how. Here, we're leveraging NVIDIA tools alongside with Mojo. To the left is the Mojo code, and to the right is the assembly code. Mojo was designed from the very beginning to work well with vendor tools. And by leveraging NVIDIA tools, we can understand and optimize Mojo kernels to best utilize the hardware. No other system out there provides such tooling and integration out of the box. And Max makes it easy than ever to develop optimized GPU code. So to summarize, Max enables seamless execution on CPUs and GPUs. And by being Pythonic, the syntax is so much easier to learn. It enables easy GPU programming. It exposes the full power of CUDA. It integrates with existing NVIDIA tools. And Max allows CPUs and GPUs to work better together. All of Max CPU features come over to the GPU. Thus, you have a unified stack that works across CPUs and GPUs. Now, I'd like to hand it back to Chris.
Thank you, Abdul. As we talked about before, GPU development today suffers from this 3-language problem. You have Python at the top, you have C++ in the middle, and you have CUDA at the bottom. And while any of these individually might be great, the reality today is that the 3 of them together produce this crazy spiral of complexity for developers. Max and Mojo are unique. Only they can unify the modern AI stack into a single Pythonic programming language with common sets of APIs. And we're not the only ones that care about this either. Our friends at Hugging Face share the same pain. They've been successfully building the technology that most of the world runs on. But to do so, they have to live in this world of custom Rust and CUDA and Python code to get anything done. Now, everybody knows how difficult it is to hire or retrain a Rust engineer. Well, Max takes that and it defines away the complexity by giving superpowers to your existing Python teams. Now, we spent a lot about the pain of the current GenAI stack, but hardware innovation isn't slowing down either. And Max is particularly helpful for the world's largest and most complex deployments of tomorrow. To talk more about this, I'd like to invite up the foremost leader in accelerated compute, Brian Catanzaro, Vice President of Applied Deep Learning Research at NVIDIA.
Thank you. Thank you for having me here. You know, our goal at NVIDIA is to accelerate the most important computational problems of our time, giving scientists, researchers, and engineers the computational tools they need to make progress. And progress in every field of work has become tied to our ability to apply compute, whether that's to invent models or to deploy them in earth and climate science, in healthcare, manufacturing. Our work in accelerated computing delivers transformational speedups to many different fields. And of course, the most important application for accelerated computing today is artificial intelligence. Training generative AI models is the most computationally intensive task humanity has ever undertaken. And NVIDIA works together with companies around the world to make it possible to train new models with unprecedented intelligence. But in order to do that, we have to improve all levels of the compute stack. All the investment that we're making in accelerated computing makes it possible to train today's most advanced models. For example, our training speed on the MLPerf LLM benchmark has accelerated by 73 times over the past few years through a combination of new algorithms, libraries, framework improvements, and scalability. And once you have a model, it's time to deploy it. AI inference has become an incredibly important computational challenge. And again, we see the value of full stack optimization and accelerated computing providing transformational speedups. We love our chips at NVIDIA. We make awesome chips. H100, for example, is an amazing chip. But we've increased inference speed by up to 2x just since August by improving investment in the underlying technologies behind accelerated inference. In the future, every application is going to be accelerated in every field. And in order to do this, we need to figure out how to get the power of accelerated computing into the hands of every developer. This means we need programming environments which are flexible and fast. And it's why we're so glad to be here today with Modular as they work to expand the reach of accelerated computing to new groups of developers and new problems.
Thank you, Brian. NVIDIA's achievements and roadmap are incredible, and we're super excited to work with you to push forward the state-of-the-art of accelerated compute.
Thank you.
Yep. Also, come with me, Brian, come with me now. I forgot something.
There's more.
There's more.
That's right. How could I forget? We are so excited about Mojo and Max and the way that developers are going to get access to accelerated computing by working with Mojo and Max. We're so excited to be partnering with Modular to make that happen.
Wonderful, Brian. Thank you. Amazing. Together, we're working hard to bring Max to NVIDIA customers around the world, including support for all of NVIDIA's latest GPUs. And we're also excited to announce that Max is coming to the NVIDIA Grace and Grace Hopper platforms. These are mega-scale CPU plus GPU data center systems optimized for LLMs. Now, we have a lot going on here for GPUs, but this is just a sneak peek. Stay tuned for more this spring.
All right. Well, Chris, today we announced a completely new AI developer platform for the world in Max.
Max is pretty incredible. We can't wait for all of you to use it. But our goal here is to give AI developers everywhere superpowers so you can unlock new capabilities. We do this by meeting people where they are and driving complexity out of the entire AI stack.
And because we want to create a more unified and simpler future for AI developers everywhere. And power the future of generative AI for the world. And the Max engine goes into preview today, and the Max platform will be available globally in Q1.
But, of course, this is just the beginning. We still have so much more coming even in the next year. I want to say thank you to the amazing Modular team, their families, as well as to Mojo developers everywhere.
AI is changing the world, and we want more people to have the tools to change it faster. There's a famous quote from Steve Jobs: "The people who are crazy enough to think they can change the world are the ones who do." So let's go change the world together.
What's it?
Right leg first, ready?
Do the robot.
Yeah, no. Nice. Amazing, man.
Amazing. Good work. Thanks, dude.